Let's go ahead and go over these answers here. So how many valence or outermost electrons does this atom of arsenic have? Taking a look here, valence, again, we're only looking at the outermost shell, so we can look at, so we can ignore everything in the center here. I'm going to go ahead and actually cross that out for us. So ignore everything in the center here. So take a look here. We should have 1, 2, 3, 4, and 5 valence electrons, which I see all of you box to the point that we can no longer even see the number 5 right there. So yes, it has 5 valence electrons. Yes, Alexis, I did get your email from your academic advisor, so I will make sure to send back some information for you. But obviously, again, watch those recordings. Eva, we also don't have live classes tomorrow, so you don't have to worry about attendance tomorrow. You're going to catch some kids, take them to get vaccinated. Oh, exciting! Very cool. All right, everyone, make sure you start opening up your notes. Feel free to scroll up to grab those links. No, you do have your other classes. Remember, science classes don't meet on Thursdays, but every other class does. Right, Jaden? So yes, good clarification. Please still go to your other classes. Otherwise, you're considered truant. Make sure you're attending your classes. All right, let's go ahead and take a look here. Remember, please have your notes open. The reason we want to have our notes open is because if we do our notes outside of class, we only get notes credit, whereas if we do our notes during class, then you get both notes and attendance credit. Again, remember that in order to get attendance, we do need to see you responding, and we do need physical evidence that you did work during class, and that physical evidence I get is from your notes.
So good morning. Just some reminders again, please do not share personal information during class. Your participation is vital and required per Insight policy. Remember, you have to be participating and you can't just sit around and ghost us. And one last disclaimer that these sessions are recorded for educational purposes. Let's get started.
We are on day 12 out of 60. We are almost to spring break. I'm excited to see some of your spring break plans in the chat. Oh my goodness. That's so cool. And taking a look here, please remember again, we do not have science classes tomorrow. You do still have your other classes. So in place of science class tomorrow, you will have a recording. Please watch the recording and get started on your newest project, the Unit 2 element project. You will be choosing an element. I specify which ones you're allowed to choose. You'll be choosing an element. You will be taking a look at some properties of it, as well as doing a little bit of research on that element. So again, that recording's coming out tomorrow to start you off on that. It's a 3-week-long project, so you do have quite a few days before you need to turn it in, but I really recommend get it started tomorrow. That way you don't feel like you're behind on it. Let's go ahead and take a look at where we are in our content.
All right, everyone. So today we are still in Unit 2, about a quarter of the way through this unit. Today we're going to be talking about ions, but we'll explain that a little bit later. Just one other reminder about this is that tomorrow is actually the first day to work on your Unit 2 element project by watching the recordings. Just be sure that that is due by Thursday, April 14th, so you do not fall behind on that project. All right. But today, since we're talking about ions, we're going to be learning a little bit more about how to balance a charge in an atom. There are going to be different types of ions called cations and anions. And to calculate the charge, we will need to be able to count protons and electrons because, of course, as we know from yesterday's lesson, protons are positive, electrons are negative, so those will influence the charge in a specific way. And we will demonstrate this by completing our notes, and hopefully we shall get an 80% or higher.
At this point, I need your notes open and ready to go with your hands up or sending me a chat. If you are on your phone, since I know you don't have the hand raise button, such a bummer. Go ahead and send me a chat or raise your hand so letting me know that you have your notes open. I'll go ahead and set a timer for another 20 seconds. Go, go, go. Links are in the chat for you. Remember to say okay for question number 1. That's just saying you understand you have to be participating in class and you have to have physical evidence that you were doing work, which is your notes. You have to pass your notes. All right, let's go ahead and do a quick brainstorm. Thank you, Louise. So electrons have what kind of charge? Take a look at our diagram or remember back to the past few days where we have defined electrons several times. What kind of charge do electrons have? What kind of charge do electrons have? Thank you, Rosa. Thank you, Julianne. Thank you, Alexis, Tara. Yes, electrons are negatively charged, and we can see that in our diagram. So even if you didn't remember the actual definition, you still have lots of context clues here. So let me grab my pen if it will let me. Here we go. So here we go. Here are the electrons. You can see they're negatively charged. Remember protons, pro means like positive, pros and cons, so those ones are positive. Neutrons start with the same 5 letters as neutral, neutral meaning 0. So electrons have a -1 charge, protons a +1, and neutrons a 0 charge. Now what I want you to think about and what the kind of way we'll think about this throughout our entire course is that electrons are like negative friends. Okay, so what I mean by that is imagine that you are a neutral atom and you gain electrons. Imagine you gain negative friends. Do you think that your life overall would become more positive or more negative? If you suddenly have a bunch of negative friends, what's going to happen to your life? Do you become more positive or more negative? Thank you, Alexis. Thank you, Rosa, Tara. Get your answers in the chat. If you have lots of negativity around you, lots of negative friends, yes, Thomas, exactly. Your life becomes more negative. In the same way, a neutral atom, neutral meaning it doesn't have a charge, if it then gains electrons, gains negative friends, then it will also become more negatively charged. I know this is a little bit hard for us to wrap our minds around because, again, it's gaining something, but it's specifically gaining the negative subatomic particle. So it actually becomes more negative. Negative friends are no good. Yes, so in this case, let's think about, let's say we get rid of our negative friends. So if we have a neutral atom that loses electrons, or if you lose your negative friends, your life should become more what? If you get rid of those toxic negative friends, your life should hopefully become more what? Yes, ideally it should become more positive. So again, same thing here. If we have a neutral atom, then it should become, oops, sorry. Oh, these tools drive me insane. Let's go ahead and go here. Positively, it should become more positively charged. All right, so if we lose electrons, again, it's weird to think about because we're losing something, but specifically, we're losing the negative subatomic particles, so we actually become more positive. So we kind of understand this conceptually, but we're going to go ahead and take a look at this also today a little bit more mathematically. So let's go ahead and we're going to talk about the concept, and then we're going to jump into a little bit of math. It's pretty simple math, though. I'm pretty confident that you all will do amazing on it. So pump yourself up. We have a little bit of math, but you're going to do great on it. So let's go ahead and move on here.
All right, so just as we were talking about before, right? So atoms, they can either gain or lose electrons to change their charge. Atoms that are neutrally charged have equal amounts of protons and electrons. We call this either being balanced or canceled out. But if the neutral atom loses or gains electrons, it changes its overall charge, all right? So basic concept here is that losing electrons becomes positive, gaining electrons becomes negative. All right, and then more specifically, in this slide, electrons, what we need to realize is that the only thing that electrons change is the charge of the atom. Remember, electrons do not have mass, or they have very little mass, and the only particle that changes the actual identity of the atom, meaning that it can change the element, are the protons. So if we're only gaining or taking away electrons, the only thing we're changing is the charge of the atom itself. All right. When an atom has a charge due to its unequal protons and electrons, all right, for a specific vocabulary word, this is called an ion. So an ion, the way we write them is with a elemental symbol such as magnesium right here, and with a superscript of whatever charge it has. So this one is going to be an ion of magnesium with a charge of +2. The aluminum has a charge of +3, and that chlorine ion has a charge of -1. Sometimes we just write a negative and the 1 is kind of implied next to it, but we don't actually write it. But the main thing here, go ahead and write charge for number 2, but this is the main equation we're going to be using for the rest of the lesson. Basically, the amount of protons plus your amount of electrons or its charge will give you the overall charge. But go ahead and write the word charge for number 2 in your notes and raise your hand when you are done.
Let's go ahead and talk about the different types of ions here. So taking a look here, we have two different types of ions that we've been talking about, both positive and negative ions. So we said that if we lose negative electrons, that's like losing negative friends. You're losing negativity, so you actually become more positive. A positive ion is also known as what is called a cation. Now, if you like cats, then this is probably a pretty easy thing for you to remember. You're like, cats are a good thing, cats are positive. So cations are a positive ion. However, if you don't like cats, there's another way to remember this. So taking a look here, if you're not like Alexis, my husband is also allergic to cats, Rosa. So if you take a look at that positive, at that T in cation, the T actually looks a lot like a positive sign. So that's another way to remember that cations are the positively charged ion. Now what's happening here again is that we've lost electrons, so now we have overwhelmingly more protons than electrons. So take a look here, I have 5 positives right here, and I only have 3 electrons, only 3 negatives. A positive 5, a negative 3 is overall going to be a positive 2. So I end up with a positive charge overall. Now, on the other hand, we talked about if we gain negative electrons, it's like gaining negative friends. You're around more negative people, so you actually become more negative. This is what is called an anion. The way to remember anion is if you take a look at that prefix an looks a lot like anti, so this one's going to be the opposite one, the negative one. This time, again, we've gained negative electrons, so now we overwhelmingly have more electrons than protons, more negativity than positivity. So taking a look here, we have negative 5 from our electrons, we have positive 3 from our protons. All right, so we have lots more negatives, so overall we end up with a negative charge, a negative charge. All right, this is going to be the answer to number 3 and number 4. Our new vocab, cation is positive ion, anion is a negative ion. 20 seconds to go ahead and finish raising your hands for number 3 and number 4. Go, go, go in your notes. We are going to review these basic math problems because, again, our equation today is going to use some basic math here. So we're going to start off with our first number here. So 4 plus negative 5, we're going to start off with 4. Point for me on the number line. Where do you see the number 4? Where do you see the number 4? We're going to do it both visually as well as mathematically. Go ahead and point with your colored pointer on the board. Yes, perfect. Yes, there it is. That is the number 4. Let me go ahead and highlight that right there for us. All right, so in the chat, now what I want to know is if I'm adding a negative number, I'm adding negativity, which direction should I actually go, to the left or to the right? If I'm adding negativity, all right, I'm getting more negative, all right, so getting more negativity. Yeah, we should actually go to the left. Perfect. So we're going to go to the left on our number line. Specifically, we need to go 5 spaces to the left. So go ahead and point for me. Where would I go? Where would I end up if I went 5 spaces to the left? 5 spaces to the left. Excellent. There we go. Yes. Yeah, so if I were to go ahead and do this, let me go ahead and pause those tools. I would go 1, 2, 3, 4, 5. And so I should end up with an answer of -1. Give me a smiley or emoji if you feel confident with that in the chat. All right, we're also going to talk about when you add a negative, this is actually the same as what other math function. So instead of in my calculator fussing around with negative signs, if I'm adding a negative, I actually also know that that is what function. There we go. I lost the word for a moment. Yes, Paul. Yes, Tara. Yes, Rosa. Exactly. It's also subtraction. So instead, we could just do 4 minus 5. Right. So 4 minus 5, same as subtraction. We don't have to put in the negative signs in our calculators. Okay, let's go ahead and try the next one. Point for me. Where do I start? Where do I start on the next one? All right, we have 5 minus -5. Where should I start? We're starting at 4. Make sure you're on the right side of the number line. Purple. There we go. Good fixing it. Yes, we should start again at the number 4 here. Perfect. Someone highlighted it for me already. And this time we're going to subtract a negative, which means we're actually getting rid of negativity. So in the chat box, which direction should I go to get rid of negativity? I'm going to move away from negativity. Yeah, this time I'm actually going to move to the right. Excellent. So go ahead and point for me then. Where would I end up if I moved 5 spaces to the right? Point for me on the board. Count them out. Where do I end up if I move 5 spaces to the right? You're at 6 spaces. There we go. Yes, so right here we should end up at 9. You are absolutely correct. So 1, 2, 3, 4, 5. We end up at positive 9. So this right here equals positive 9. Now, taking a look at that, that means that when we subtract a negative, that's actually the same as what function? Subtracting a negative is the same as what function? Tara and Alexis already had the answer for me before I even said it. Mind readers, or just very good at predicting me. Subtracting a negative is what? Subtracting a negative is the same as addition. So I could just put 4 plus 5, which again also equals 9. So again, that's what I want you to pay attention here, is that when you add a negative, that's actually the same as just plain old subtraction. And when you take away a negative, that's the same as plain old addition. That's going to help us out with today's concept. So let's go ahead and actually try this out. We saw an equation earlier. We're going to go ahead and begin to actually apply it. What is the charge of a beryllium, Be ion, with 2 electrons? I'm going to annotate what's important here, that it has 2 electrons, and that it is, in fact, beryllium. Taking a look at our equation, we actually need to know both protons and electrons. So taking a look here, we have an issue. We need to know the number of protons in beryllium, but aha, we actually know the number of protons based on our periodic table. Point for me on the board. Where can I find the number of protons for beryllium? Where can I find the number of protons for beryllium? See 2 people up there. Let's get some more participation. 4 people, 5 people. Yes, excellent. Perfect. Yeah, we find it right at the top there. That is our atomic number. Atomic number shows that beryllium should always have 4 protons. Otherwise, it wouldn't be beryllium, right? So we always have to have 4 protons in beryllium. So even if a question doesn't explicitly say how many protons there are in something, you should always be able to figure it out from our lovely periodic table. So let's go ahead and start plugging this in. What should I plug in for my proton charge? Again, take the number of protons, and it should be a positive number. Protons are positive. What number do I plug in here first? Protons, how many are there? And make it positive. I see Rosa, I see Alexis, I see Haley. Positive protons, Umeza, Juliane, Shane, Creek. Yes, this one is going to be a positive 4. I don't need to write the positive, that's just assumed. That's a math. That's how we traditionally do math. Now over here for our electron charge, we need to make it negative. So how many electrons do I have? And make it negative. How many electrons do I have? Make it negative. Thank you, Tara. Thank you, Alexis. Thank you, Rosa. Yeah, exactly, Haley. So I should have -2. I actually already have that negative in there for us, so -2. And remember, anytime we add a negative, that's the same as subtraction. We just went over this. So adding a negative is the same as saying 4 minus 2. Go ahead and tell me in the chat, what is my answer? I already saw lots of people with it earlier. You're way ahead of me. 4 minus 2 should give us a charge of amazing. Eva, double check that math. I see lots of people in there. Yes, this is going to give us 2. Perfect, Eva. Great correction. Yes, Sophia. So how would I write this out? Let's go ahead and take a look here. When we write out ions, we mentioned we need to include the abbreviation for beryllium. Tell me in the chat, what's the abbreviation for beryllium? Remember, capitalization, lowercase matters for abbreviation. So make sure that you are capitalizing and lowercasing the correct things here. Yeah, so it's capital B, lowercase e. Okay, and then the superscript, all right, which you can show me in the chat, would be like a caret. Superscript should then be +2, right? So the way that we write this is we always put the number first, so we put the 2 first, and then we have to put the sign as well. So we have to specify it's a +2. So don't forget the positive when you write charges. Another way you could write this, like in a chat box, would be BE with a caret, +2, so that we know it's a superscript. Okay, smiley faces emojis in the chat box if that makes sense. Smiley faces and emojis in the chat box if that makes sense. Yeah, Shane, I haven't told you what to do for question number 5 yet. You just got to wait for me, because I have not told you to do number 5 yet. Just wait. I know, it's hard to be patient. Excellent. So this is the answer to number 5. You only need to put in the number 2. Again, I'm just going over notation because we will be using this notation throughout class, so I want to make sure we actually get a chance to see that notation. So put in the number 2, that's our charge for number 5. You have 20 seconds to get that saved. Go, 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 raise your hands. We'll try another problem together. So taking a look here, we want to know about the charge of an oxygen ion with 10 electrons. Again, can I figure out the number of protons? Yes or no? Tell me in the chat. Can I figure out the number of protons? Absolutely. Point for me on the board. Where do we find the number of protons? Always for oxygen. We can always find protons. Yes, and it will always be 8 for oxygen. Yes. So oxygen must always have 8 protons. Otherwise, it wouldn't be oxygen. Again, that's based on our atomic number right here on our periodic table. So taking a look here, what should I plug in for protons? Find the number of protons we just determined and make it positive. What do I plug in for protons? All right, yes, we should have positive 8. Awesome, so I'm going to plug in a positive 8 for protons. And what should I plug in for the electron charge? Again, how many electrons? And make it negative. Make it negative. Double check that, Shane. Make it negative. There you go. Perfect, Shane. Correcting that. I see Luca. I see Paul. Yeah, this should be a negative 10, again, already written up there for us. So again, we can just make subtraction, make this into subtraction, 8 minus 10. This is like you have $8 and you try to spend 10 of them, you should end up in debt. So what is the answer for number 6? You should end up in debt. I don't know why I'm smiling for that, but make sure you're thinking about if your answer is positive or negative. Yeah, you should end up with a negative charge. Cool. All right. Go ahead and in the chat box, please tell me then, how would I write this as an ion? Again, give me the capital letter as the symbol. Use a little caret to show me I have a superscript. And what would be that charge? Again, the number should become before the charge. There we go, Tara. Excellent. So yeah, so the way that you should write this out is capital O with a little caret to show that it's a superscript and a 2 negative. Again, if you were to actually write it out by hand, it would look like this. O with a 2 negative at the top. So the answer for number 6, again, is just the number. So you just need to put in -2. Do not forget the negative. Otherwise, the computer will mark it as incorrect. You have 20 seconds to raise your hands for number 6.
Here is looking at gallium with 20 electrons. So if we have 28 electrons and we're looking at gallium, gallium is right here. How many protons should gallium have based off of the atomic number? Thank you, Paul. Thank you, Sophia, Matt, everyone in the chat. Awesome job. Yes, it's going to be 31 protons. So our positive number, our proton charge is going to be 33. Or I'm sorry, 31, I misspoke. And then if we have 20 electrons, what is going to be our negative number? I already see it, people writing in there. Awesome. Yeah, it's going to be 28. So very simple math. It's just going to be 31 minus 28. 31 minus 28. That is going to give us a charge of what? Who can tell me in the chat? Yes, it's going to be 3, right? And we want to make sure it's a positive 3 because positive 31 is larger than negative 28. So now for number 7, the charge is going to be 3 or plus 3. But how do we write this ion? How do we write this ion? You got some, Jasmine? Yeah, it's going to be Ga caret 3 plus or plus 3. So let me write out my number and my sign with it. It's important we put the sign with it because with elemental symbols like this, if we don't put a plus or a minus, no one is going to really know when they look at our work what sign or charge we were really trying to communicate. Yeah, no Nikki numbers. So please raise your hand for number 7 when you are done. All right, so for this one, we're going to be looking at iodine with 54 electrons. Iodine, I'll mark it for us, is down here. How many protons am I looking at for iodine? 53, very good, guys. So our positive number is going to be 53 in our equation. So our negative number should be the amount of electrons, which will be, yes, exactly 54. So it's 53 minus 54, which will give us exactly, Shane, -1. Tara, awesome. Umeza, yes, -1. All right, so make sure for number 8 that you mark -1 for your answer in your notes. But now, who can tell me how do we write this ion? How we write out the name of the ion. Yes, it can be I caret with just a negative sign, or it could be 1 negative or -1. Yeah, either way, that should be fine. But remember, for your notes, your only answer should just be -1.
All right, so for this last one, I'm going to go ahead and help you annotate this one, and then we're going to go ahead and you need to finish it on your own. So what is the charge of a calcium ion with 18 electrons? Taking a look here, we need to know how many protons are in calcium. How many protons are in calcium? I see Tara, Rosa, Umeza, Shane, Camila. Yes, I love all the confidence. You can see down here that calcium has an atomic number of 20 and therefore should have 20 protons. So plugging that in here, I need to go ahead and plug in the positive proton charge. What should I plug in here? Positive proton charge. What should I plug in here? How many protons? And make sure it's positive. How many protons? Make sure it's positive. Thank you, Rosa. Thank you, Tara. In the chat, make sure you're participating. Yeah, this one is going to be the positive 20. And the electrons, how many electrons? And make it negative. Make it negative. Again, what did we annotate? Make it negative. Yeah, this one should be -18. Do not put answers in the chat, but 20 plus -18 should be the same as 20 minus 18. If you need to check your answer, we're in the Q&A area, and only the Q&A area. Please do not put it in the main chat. You have 30 seconds to answer number 9. Go, go, go. We're out of time, so please work fast.
Go ahead and submit your quiz if you haven't already. Tell us how you did, or does not need us to go back to any other problems. Please feel free to leave class, as we need to get to ours pretty soon here. Have a great day, everyone, and I'll see all you guys on Friday.